Hi everyone, this is Sai Santosh TGT JNV channel. Today we start with the 12th class NCERT syllabus Mathematics 1 first part, and in this Mathematics 1 chapter 3 start with the chapter 3 matrices. Okay, so then matrices are one of the most powerful tools in mathematics. Matrices are one of the most powerful tools in mathematics because of this is the term matrix. What is term matrix? Matrix is the singular form. Then matrices is the plural form of this matrix. Matrix is the singular form and matrices is the plural form. Okay, and in this introduction of this matrices, the origin of mathematical matrices lie with the study of systems of simultaneous linear equations. In the important chapters of this matrices and also in matrices concept, matrices are used for describing the quantum mechanics of atomic structure, designing computer game graphics, analyzing relationships, and even plotting complicated dance steps. First, we learn with the definition of matrices. Okay. A matrix is an ordered rectangular array of numbers or functions. The numbers or functions are called the elements or the entries of the matrix. So here some of the examples. So in this definition of matrices, so this is the rectangular array. Here in this matrices, these numbers are called entries or elements. Okay. In this example, we have -2, 5, 0, 3, 3, -6. How many elements here we have? 6 elements. So these are one of the example, and B is the another example. We have in the 9 elements, and C, example C is the we have 6 elements. This is the rectangular array, and in this rectangular array, rows are called horizontal. Okay. Horizontal ways are rows, and vertical lines called columns. Vertical lines are called columns. These horizontal and vertical combined elements is called, and rectangular array is called matrix form. Okay. Then next we move to the order of a matrix. Okay. A matrix having m rows and n columns. Just observe that m's indicated with the small m and n indicated with the columns is called a matrix of order m by m. What is order? Move with the example. So first, what are these called? Elements. Elements of the matrix. Then how many rows here? Rows 1, 2, 3. So indicating here is 3. Number 3 is a rows. And how many columns we have here? 2 columns. So 3 cross 2 means 3 by 2. It is the order. Okay, it is the order. It indicates the size of the matrix. Okay, here what is the order? 3 by 3. 3 rows and 3 columns. And here what is the order? How many rows? 2 rows. How many columns? 3 columns. This is the order. Size of the matrix is also called as the order of the matrix. Here, example of this order of matrix is we have the matrix is the elements with the elements A11, A12, A13 and up to so on A1n. And second row is A, and second row is with the A21, A22, A23, so on A2n, and up to last the AM1, AM2, am3 and so on up to amn. So here we have rows and columns a11 to amn. So how many elements we have? How many rows? How many rows? First row, second row, third row, so on mth row, m, small m. How many columns? First column, second column, third column, up to so on nth column. So we have n columns. This is called order. This is called order of the matrix. Okay, order of the matrix of like a symbol is A or B, anything. Here observe that one point is the symbol of the matrix is in capital letters, and the elements of the matrix are symbolized with the small letters. Numbers or anything else, those are symbolized with the small letters. This is called elements. Okay, this is the m by n matrix, order of the matrix. Okay, now we start with the example. Construct a 3 by 2 matrix whose elements are given by Aij is equal to 1 by 2 into mod I minus 3j. Here Ij indicates the one of the element in the matrix, where I indicate the place of row and j indicate the place of column. So here is the Aij is the one of the element of the matrix. This value is given by 1 by 2 into modulus I minus 3j. This is the given question. Construct a 3 by 2 matrix. How many rows? With the how many rows? 3 rows and 2 columns. This is the order. 3 by 2 matrix elements. Okay. So then solution. In general, a 3 by 2 matrix A is equal to A11, A12, A21, A22, A31, A32. This is the order of the matrix is with the 3 by 2 matrix with 3 rows and 2 columns. This is the symbol. Now given Aij, how is it? What is it? 1 by 2 into I minus 3j. So here I indicates the rows. We have 3 rows, and j indicates the columns. We have 2 columns, and therefore first separately 1 by 1 element is calculated. 1 by 1. First one is first row and first column. First row and first column, that is place of A11. A11 is equal to half mod I minus 3j. I is the 1 minus 3j. J is the first column. 3 into 1. So then we get 1 minus 3. 1 minus 3 is a minus 2. Okay. 1 by 2 into mod minus 2. What is the mod minus 2 value? Is the plus 2. Then get value is 1. Modulus value is if minus or plus, that we get the positive value. Okay. Then we get the value 1. Next at the value A12. A12. A11, the next A12. A12 as it is 1 by 2, 1 minus 3 into 2. We get value is 5 by 2. And also A21, next. A21 is the second row. So we get in the substitute in the formula half into mod 2 minus 3 1 is equal to value is half. As is A22 is half 2 minus 3 into 2. This value is 2. Okay. Here in all values, mod value is changed into positive value. If we have the next A31 is equal to half 3 minus 3 into 1. So here 3 I value and 1 is the j value. Then we get 3 minus 3. Anything is 0 into anything is 0. And last value A32. This is the A32 is equal to half 3 minus 3 into 2. This value is 3 by 2. Okay. 6, 3 minus 6 is the minus 3. Modulus minus 3 is 3 by 2. So we get these 6 values. Okay. Hence the required matrix is given by A is substitute in this matrix. We get all values. What are the values here? First one is a 1. Next one is 5 by 2. Next one is off. Next one is 2. Next one is 0. And last one is 3 by 2. Hence we get the value of the matrix is with the 3 by 2. So we constructed the a 3 by 2 matrix. Here we constructed, okay, 3 by 2 is the constructed matrix we get. Okay, we move with the types of matrices. First we learn the simple types of matrices. So how many types of matrices we have? Some of the matrices. So first, row matrix, column matrix, square matrix, rectangular matrix. We have different types of matrices. Okay. So first of all, then first to write row matrix. So then the definition of row matrix is that if we have a rectangular matrix, so rectangular and square matrix are next we discuss about these two matrices. First, the row matrix is we have the matrix has with only one row, that is called row matrix. For example, only one row. For example, take any sum of the values 2, 3, 0, minus 2. Like I will take only one example and also another example 2, 11, minus 8, sum. Okay. So here is only one row. How many rows here in this matrix? Only one row. And in this matrix B, only one row. How many columns in the first matrix? 4 columns. That is not important. Here in the row matrix we have only one row in the particular matrix. That is called row matrix. So here the order is one row and 4 columns. This is the order. And in the matrix B is row matrix. Here is also 1 by 3. It is indicated by cross, but it is called 1 by 3. It is called 1 by 4. Okay. This is the row matrix. If we have only one row in this matrix is called row matrix. And column matrix. Here same as it is vice versa of the row matrix. Matrix A have only one column. Matrix A have only one column. This is called column matrix. Matrix B have, like some matrix B have only one column. With a not matter about the rows. Here like about 5 rows. Minus 1, 0, 3, 2, 1. 5 rows. How many columns we have here? Only one row. So column indicated by here in the next place. Here is the first rows 2 by 1. How many rows? 5 by 1. Here second number is indicated for the columns. Okay. So the matrix has, if the matrix has only single column is called column matrix. Okay. The next third one is a square matrix. So number of rows is equal to number of columns. Then it's called square matrix. For example, the matrix 2, 3, 0, minus 1. How many rows here? 2 rows. How many columns here? 2 columns. Then we get it is a 2 by 2 matrix. So rows and columns are equal in this matrix. This is called square matrix. 2 by 2, 3 by 3, 4 by 4. That is anything else. M by M. Like as M by M. For example, here we take 3 by 3. Minus 1, 0, 4, 3, 1, 2, 5, 6, 8. This is the 3 by 3 matrix. This is the square matrix. Okay. And rectangular matrix is the fourth one. Here number of rows is not equal to number of columns. Then simply like as 1, 2, 3, 4, 5, 6. This is the How many rows here? 3 rows. How many columns? 2 columns. So then these two are not equal. So this is called rectangular matrix. Okay. So number of rows is not equal to number of columns. Then we observe that here row matrix. Row matrix is square or rectangular? This is the rectangular matrix because of number of rows and number of columns are not same. Okay. And also in the column matrix also number of rows and number of columns are not same. These two are called rectangular matrix. These two are called rectangular matrix. Okay. So then diagonal matrix. Fifth one is the diagonal matrix. What is the diagonal? Diagonal means what is that? Diagonal is symbolized, and diagonal matrix is the only view at the square matrix. Okay. So the diagonal matrix like as D, diagonal matrix is D is equal to like as diagonal matrix means here diagonal elements are only in the positive or negative values, non-zero elements, but remaining non-diagonal elements are zeros like as 1, 2, 3. Take 1, 2, 3. Remaining other elements are zeros. Okay. These 1, 2, 3 values are diagonal elements. Other zeros are non-diagonal elements. So these values are non-diagonal elements. Only first like as A11 element to A33 element. A11 to A33. First element to last element in the crosswise. These elements are in this non-zero elements. Remaining elements are in zero elements. For example, another example is for the 4 by 4. Take as 6 minus 1, 2, 4. Remaining elements, all other elements are zeros. Remaining all other elements are zeros. Okay, sorry. In this 6 minus 1, 2, 4. This is the diagonal elements. Only diagonal elements are in the positive or negative, non-zero elements. Remaining all other elements are zeros. Then it is called a diagonal matrix. Okay. Diagonal matrix is possible at only in the square matrix. 2 by 2, 3 by 3, 4 by 4. Like m by m matrix. Okay. Not m by m. Only m by m. Okay. Then next we move with the scalar matrix. Then what is the scalar matrix? Here we have already learned about the diagonal matrix. So in this diagonal matrix, like as take 3 by 3 matrix. What is the diagonal matrix? Here we have only diagonal elements are zeros. Non-zeros. Remaining elements are non-zeros. In the scalar matrix, only diagonal elements are same, like as take number 3. Remaining other elements are zeros. This is called a scalar matrix. This is called a scalar matrix. Take another example. The matrix B is like with the 5 or minus 5, minus 5, minus 5. Remaining other non-zero, non-diagonal elements are non-zeros. Only diagonal elements are in the same, then other elements are zeros. Then that is called a scalar matrix. It is also called diagonal matrix, but diagonal elements are in the same values. Those matrices called scalar matrices. Okay. So then also another example of scalar matrix is take as 1 0 0 0 1 0 0 0 1. What type of matrix it is? It is a scalar matrix. Scalar matrix because of 1, that is same element. Remaining other are zeros. Okay. This is also called as identity matrix. This is also called an identity matrix. So scalar matrix is directly identity matrix with the diagonal elements are ones. Okay, so I mean this is the identity matrix. It is indicated with the not as C, like directly we get I. I means first letter, identity matrix. 1 1 1, these diagonal elements are same, and should these diagonal elements are in the 1. 1 is the main important number in the identity matrix. Okay, this 3 by 3 or 2 by 2 example, 1 0 0 1. This is the identity matrix. This identity matrix also called as a scalar matrix, because of here is also 1 and 1, these are diagonal elements, so these are same and these are ones, so it is a diagonal matrix and scalar matrix and also identity matrix. Okay, so here we write I2, I3, I4. How to write it? What is the order here? 2 by 2. Simply it is I2. Okay, this is the 3 by 3 matrix. It is I3. I guess 3 by 3 means same. Okay, these are identity matrices. And next, zero matrix, already you know that. All of you know that the matrices with the zero elements, all elements are zeros or all entries are zeros in the particular matrix A is called zero matrix or null matrix. Zero matrix or null matrix. Okay, so with the any order 3 by 3, 2 by 2, anything else, but it is in the square matrix, that is called zero matrix. Okay, next, ninth one is the upper triangular matrix. So here compulsory in this triangular matrices we have two different types. Ninth one is the upper triangular and 10th one is the lower triangular matrices. Upper and lower triangular matrices are formed into only the square matrix. What is the square matrix? 3 by 3, 4 by 4, 5 by 5, anything else. But here upper triangular matrix, already you know that the triangulars. Okay, so here like I form one matrix like as 1 2 3 0 minus 4 3 0 0 7. Okay, here what we observe that here this is the 3 by 3 matrix is clearly, but what is the here diagonal? 1 minus 4 7. So then 1 minus 4 7, like as upper place of these diagonal elements are all are non-zeros, lower part of the diagonal are zeros, so then it is called upper triangular matrix. And vice versa, lower triangular matrix is like simply lower triangular is a 1 2 3 0 0 2 0 8 9. This is the lower triangular matrix, because of here the values of the elements are zeros on the upper place or above of the diagonal elements is called the lower triangular matrix. Upper triangular and lower triangular, these two are different triangular matrices. Okay, in this video the last concept of the matrices is trace of the matrix. Trace of the matrix. Okay, what is a trace? Trace of the matrix is also the sum of the diagonal elements, which means here this trace of the matrix is only possible in the square matrix. Like as already you know that the square matrix, like take as 4 6 8 9. This is the 2 by 2 matrix. This is the 2 by 2 matrix. Here because of it is the square matrix, so then what is the diagonal elements here? 4 and 9. The sum of diagonal elements, sum of diagonal elements is trace of the matrix. Trace of this is A, then we get trace of A is equal to 4 plus 9. is equal to 13. This is the trace of the matrix. Like as take B 3 by 3 matrix, because of we have only here use square matrices. Okay, number of rows and number of columns are same. So like as take another example, 3 by 3 is minus 9, 4, 6, 0, 8, 11, 6, 12, minus 8. Then what is the trace of this matrix? Sum of diagonal elements, right? Trace of B is equal to, what are they here? Diagonal elements sum, minus 9 plus 8 and minus 8 with the symbol minus. Okay, minus 8 plus 8 cancel, is minus 9 is the answer. That is the trace of the matrix B. Okay, so and remaining definitions of the matrices and operations of the matrices are learn with the next concept, like as in the next video. Thank you one and all.